Welcome to this explainer on mastering scientific arguments. You know, if you've ever watched a student just completely guess at an answer and thought, how do I help them actually prove their point? Well, you are in exactly the right place. Today, we're going to unpack a framework that takes the messy, complicated world of science and structures it into incredibly clear, undeniable proof. Here is our agenda for today. We're breaking down the CER framework step by step. We'll cover thinking like a scientist, making your claim, backing up with evidence, connecting with reasoning, evidence versus reasoning, and finally the scientific explanation checklist. Let's jump right in. Section 1. Thinking like a scientist, moving beyond opinions. Let's kick things off by looking at how scientists actually think, because, spoiler alert, they don't just state their opinions. They build highly structured explanations. To really understand how students learn to master these scientific arguments, imagine you're a detective investigating this exact question. Which ramp makes the Hot Wheels car travel the farthest? It seems like a fun, simple game, right? But to a scientist, this is a puzzle waiting to be solved with absolute precision. You can't just say, well, I think the big one works best because it looks fast. Nope, you have to prove it. To solve that puzzle, we move to Section 2, making your claim, answering the question. The very first step in our investigation is establishing the C in our framework, the claim. A claim is absolutely not a wild guess. It's your direct, specific answer to the scientific question at hand. For students learning this process, the claim is basically the anchor. It's the destination they're trying to reach. A strong claim has to do three things. It must answer the prompt directly, it has to be highly specific, and most importantly, it's got to be something you can actually back up with evidence later on. This brilliantly illustrates the difference between a beginner's guess and a true master's approach. A weak claim simply says, the car went far. It's vague, right? It doesn't really answer the specific question about which ramp is actually best. But a masterful claim says, the car traveled the farthest when it was released from the highest ramp. It's exact. It gives a definitive answer that sets up the rest of your argument perfectly. Section 3. Backing up with evidence, proving your point. Okay, so we've got our specific claim, but now we need to prove it using the E in our framework, evidence. Evidence relies strictly on what you observed, measured, or learned, things like data tables, graphs, or experiments. It entirely leaves personal opinions at the door. When students are mastering scientific arguments, this is the exact moment they learn to detach their feelings from the facts. It is literally never about what you think happened. It is 100% about what the data shows happened. Notice how introducing real data completely transforms the argument. Replacing a vague, subjective feeling like the high ramp was better with hard numbers, like traveling 185 centimeters versus just 92 centimeters, creates concrete, undeniable proof. I mean, you simply cannot argue with those numbers. That right there is mastery. Moving on to Section 4, connecting with reasoning, the why behind the data. We have our claim and we have our concrete numbers, but to really lock this explanation down, we need the R, reasoning. Think of reasoning as the crucial glue that connects your raw data back to your claim by bringing in established scientific concepts. Honestly, this is usually the hardest part for students to master because it forces them to take a step back from their specific experiment and apply universal scientific laws. It answers the big overarching question, why does this specific data prove my specific claim? Let's look at how this applies to our experiment. For our Hot Wheels car, we explain that a higher starting position means more gravitational potential energy, which then seamlessly converts into more motion down the ramp. See what we did there? We aren't just saying, hey, the numbers are bigger. We are introducing the fundamental science ideas of potential energy and motion to explain why those numbers are bigger. Now, here is an absolute game changer of a template. When students get stuck on how to actually phrase their reasoning, having them fill in these exact blanks acts as a perfect set of training wheels. My evidence shows blank. I know this supports my claim because blank. It literally forces the writer to physically link the data to the scientific justification. So the whole CER formula flows super logically. Step 1, you state what you think. Step 2, you back it up with data. And step 3, you explain why that data makes sense scientifically. This 3-step flow is exactly how students learn to build robust, unshakable arguments that can withstand scrutiny. Claim, evidence, reasoning. It's a clear pathway from basic observation to absolute mastery of a topic. Section 5, evidence versus reasoning, the most important difference. Let's take a second to address a super common stumbling block in this framework, mixing up evidence and reasoning. The golden rule you want to remember is that evidence tells you exactly what happened, while reasoning explains why that event proves your point. If you ever find yourself just repeating your numbers in the reasoning section, well, you haven't actually provided any reasoning, you've just stated the evidence twice. Take this plant experiment as a quick example to illustrate the difference. Our evidence is simply the raw data showing the fertilized plant grew 14 centimeters, while the unfertilized one grew only 8 centimeters. That is the what. It's just a snapshot of the reality we measured, nothing more. Now let's see how we build an actual argument out of that. Saying the plant grew more adds absolutely nothing new, but a master's reasoning explicitly states that fertilizer provides essential biological nutrients, connecting that 14-centimeter measurement directly to the underlying science of plant health. Finally, Section 6, the scientific explanation checklist, ensuring a solid argument. To wrap this all up, let's look at a quick checklist to ensure your scientific argument is completely bulletproof. Before you finalize any explanation, run it right through this gauntlet. Did you answer the question? Is your evidence specific and measurable? Does that evidence actually support your claim? Did you explain why it supports the claim? And finally, did you use appropriate science ideas to tie the whole shebang together? If a student can confidently check all 5 of these boxes, they haven't just answered a question, they have completely mastered a scientific argument. By mastering this claim, evidence, and reasoning framework, always remembering C is the what, E is what makes you think that, and R is why does that make sense scientifically, you aren't just becoming a better science student. You're becoming a sharper, more analytical, critical thinker in literally every area of your life. You now have the tools to look at the world, demand real evidence, and understand the deep reasoning behind how things actually work. So, equipped with the CER framework, what real-world mystery will you investigate next?